No.
Drink one more, see what happens. Maybe we'll get superpowers.
I drank 3 monsters at academic team one time.
Okay, there's my first question for you. You're given a 2.0 molar solution of sulfuric acid. What's that mean? See if you can answer that question. So if you have a 2.0 molar solution of sulfuric acid, what do you really have? See if you can answer that. Addie, what do you have? What'd you write down? Okay. It can, if I write it like this, what would you tell me over here? And I write this. What goes on top? Carter?
Isn't 2 of the 1?
That is correct, but we have to be more specific because that means nothing.
2 moles of
Yeah.
H2SO4.
2 mole
Solution.
H2SO4, 1 liter solution. Notice I didn't ask you to express the electrolyte concentration or any of that stuff. I just wanted you to tell me, what does this really mean?
Yeah.
So then I could ask you, let's say you're given this 2 molar solution. And I want you to think of the most clear way to say this. I want you to make 2 liters of solution. And I want you to do that conversion. And I want to know, the big question is the number of moles present. So I would start like this. I would say moles H2SO4 and then I would set that equal to the volume of the solution that I want, which is 2 liters. Yes? That makes sense? And then I would have to use what I already know about my solution. So that I know I have 2 mole of H2SO4 in 1 liter. I've gotten my liters cancel out. I'm left in moles. And it becomes a really simple multiplication problem. So you really just have to find a way to use what you know about the molarity and look at the quantity, like the where you want to go, and find a way to use it. So let me ask you another one. What volume,
We can't see it.
can you now?
Yes.
Just a little bit. Right there.
Whoops. What volume we'll make this a 0.3 molar solution of, we'll stick with our sulfuric acid, H2SO4, is needed to supply 2.0 mole H2SO4, 2.0 moles of H2SO4. So I want to know about volume, I want to know about liters. So I'm going to say liters of solution is equal to, what do I have? What am I given here? I've got this and I've got this. So I usually save my molarity. So I'm going to say 2.0 mole H2SO4, and remember that's just like that's over 1. And I know my molarity. When I look at my molarity, it's moles per liter, right? Now, pay careful attention to this. It's important. When you're working these problems, you can always use the reciprocal of molarity. Do you know what I mean when I say that? I can flip the units. So it can be moles per liter, it can be liters per mole. It depends on how I need to use it in the problem. So this 0.3 molar solution really tells me 1 liter over 0.30 mole. There, I just used the reciprocal and it lets me work the problem. So my moles of H2SO4 cancel out. I'm going to end up in liters of solution, which is where I want to be. I just have to do the math. What is 2 divided by 0.3? What?
Wait, 2 divided by?
Well, I have 2
divided by
here.
0.3.
Yeah, what's 2 divided by 0.3?
6.66 would be.
6.66, so we'll make this 6.7.
Would it not be 0.3 divided by 2?
No, 2's on top. 3's down here.
Why is 3 down?
Because I need my units to cancel out. That's what I was talking about, how I can use the... This is moles. Up from this part of the problem, this was in moles of H2SO4. I took my molarity, and I instead of using moles per liter, I can flip it and use liters per mole also. So I have moles up here and moles down here. They cancel out, and that leaves me in liters of solution.
How do you have moles when you have molarity?
Because molarity is mole per liter. And when I wrote 0.3 molar, that's saying 0.3 mole per 1 liter.
Okay.
So then I took that, like I took that knowledge that I had, and that's why I said pay attention, listen to this, it's important, and I flipped it and used the reciprocal because I'm allowed to. It always works.
Why doesn't the liter unit cancel out?
Because this is what this is telling me the number of liters of solution. This is outside the equation. It's what I'm solving for. This is not over liters. It's just over 1. Just like we used to do in the old easy stoichiometry stuff. Okay? Yeah, so when I then actually do the math, it is, that looks about right, 6.7 liters of solution. Now try this one. I'll just do a repeat with some different numbers and see if you can work your way through it without looking at what we just did. What volume of a 4.5, oh doggone it, I'm gonna have to get this fixed. 4.5 molar NH3 solution is needed to supply 7.8 mole NH3. Now see if you can set that up without looking at what we just did. And then if you can't, look up there and follow the thought process through. Remember, you're solving for liters of solution, so you set that equal to your equation. When you have an answer, stand up. I should figure out the answer. Okay, almost. Okay, Annika, what's your answer?
1.73 liters of solution.
Is that what y'all got? Good, that's what I got too. Okay. All right, I'm going to show you one more thing, then I promise I'll be done.
Come on, Carter.
You'll like this one, it's pretty simple. Oh no. I'm going to give you one more and see if you can figure it out without me talking you through it. I'm going to have you break into your lab partners for a minute. Okay. How many grams we'll use this again because we've already got it calculated, of sodium sulfate are required to make 0.30, no, 0.350 liters of a 0.5 molar solution. Okay, so there's your question. I want you to move with your lab partner, and I want you to see, I'm going to give you about 3 minutes, see if you can figure it out. And we'll come back together. You should already have the molar mass of sodium sulfate in your notes. What is it, 142? Follow your units through. You have to show how your units cancel out. How you get all the way from having liters and molarity to grams. Okay, when you're done, come back up front. Or like when you're like, I don't know what to do, come back up front. Whatever it is. Okay, raise your hand if you got an answer. Colin, what'd you guys get for an answer?
24.9 grams.
24.9 grams. Raise your hand if you got that same answer. Okay, that is a correct answer. Now, let me show you my setup. I was given this 0.350 liters, correct, in the initial problem. And I was also given this molarity in the problem. So I had to use those two things to get my units to cancel out. Once I got my liters canceled out, then I could use my mole up here to make my simple stoichiometric equivalency of moles to grams, and then use that to get my grams. And my grams, I didn't write it down, but it was 24.9 grams, I believe. Is that what you said, Colin? Yeah. Now look at that and see if it doesn't make sense, ask questions. Because there were a couple of you that still, I don't think, got it set up. I'll give you some more to practice later.
Thank you.
All right, the one other thing I want to show you today is called dilution, and it's actually fairly simple. Can I move this? Are you guys good? Okay.
Peachy.
I know you want me to just be done. I know.
You're right.
You never even want me to talk. All right. Dilution. Are you tired of telling me that?
We shouldn't tell you.
So this is what I do. I buy solutions that are extremely concentrated. And before I can let you use them, I have to go through the process of dilution. So this takes a concentrated solution, which is called a standard solution. Like when I buy hydrochloric acid, it's 12 molar hydrochloric acid. If I buy nitric acid, it's 14.3 molar nitric acid. And then everything that we use in here is somewhere between about 0.5 and 6 molar. So I have to dilute my concentrated standard solution.
Is the solution abbreviated?
Yeah.
SLN?
SOL or SOLN, either one. Basically, this is a way to lower the concentration in lab. And it's just done by the addition of pure or deionized water. It's very easy math. The math is easy. The process of doing it is a little more difficult. Not doing the math, but doing the dilution. So basically, I can set this up as moles of solute before dilution equal moles of solute after dilution. So I don't change the concentration of moles. I don't change how many moles are there. So let's say you are preparing a concentration from another concentration. We'll say it that way. So it would look something like this. It might say prepare 250 milliliters of a 0.1 molar solution of, we'll use the same old thing, sodium sulfate by diluting 1 molar Na2SO4. Well, you have to find the missing link, right? There's an easy way to do this. Because of the fact that I'm mixing different molarities, I can use the moles or the molarity of my concentrated solution times the volume of my concentrated solution, and I can set it equal to the molarity of my diluted solution times the volume of my diluted solution, because I'm mixing those two things, right? And then I can plug in everything I know and solve for the one I don't know. So this is a formula you're going to want to remember. It usually looks like this: MCVC equals MDVD. In these problems, it doesn't matter if you convert really your milliliters at the beginning or at the end. It doesn't change anything. I usually do it at the beginning. So I would say, which one is my concentrated solution? What do I have to use? I've got a 1 molar and a 0.1 molar. So my concentrated solution is the one with the higher number out front. So I'm going to use 1 molar times, I don't know how much of that volume I need. And I'm going to set it equal to 0.1 molar times 0.25 liters and solve for my unknown. Which is actually pretty easy. So I would have to use 0.025 liters of my 0.1 molar solution with that to get the desired concentration. Very last one. I'm going to ask you one question. How many milliliters of 3 molar sulfuric acid are needed to make 450 milliliters of, bless you, 0.1 molar H2SO4. Calculate. Set it up, calculate. Look for your concentrated, look for the one that's not concentrated, get them on the right side, or the diluted, I should say. So basically this is asking you what volume of concentrated acid do you need to dilute. Hey, what's the answer? Did you get it, Rachel? 0.015. Is that in liters or milliliters? Liters. So I want to know milliliters.
15 milliliters.
So that is correct. That is 15 milliliters.
Now, do you wish us to convert it to meters for our answer?
Well, it says how many milliliters.
So no.
Now let me tell you a secret. You don't have to, if you're asked for milliliters, you don't even have to convert it here. You could have put 450 milliliters right here, and it would have worked out fine. Okay. All right. I have 4 problems I want you to do. I'm going to be done talking. Miss Kinley, I hope you feel better soon.
Bye.
Bye, Goodman. Yeah.